All right, let's talk about that one single, unbreakable rule of math we all had drilled into our heads. You cannot divide by zero. It's like the first commandment of arithmetic, right? A fundamental law. But what if it isn't? I mean, what if that rule wasn't some cosmic law, but, just a convention, something we all agreed on? And what if flipping that one little switch, changing that one single rule, could completely unlock the next generation of technology? We're talking indestructible AI, super efficient computer chips, the whole shebang. So just take a look at this table. It really lays it all out. In the math we all know, as you divide 10 by a number that gets closer and closer to zero, the answer just explodes, right? It races off toward infinity. And the second you actually hate zero, boom, the system breaks. You get an error. But this idea, the Balabachi axiom, it proposes something, shockingly simple. It says 10 divided by zero is just 10. Okay, to really get how kind of wild that idea is, we have to go back and appreciate the rule we're talking about breaking here. For literally centuries, dividing by zero wasn't just a bad idea, it was seen as a flat-out mathematical impossibility. Let's dig into why. So this graph here really paints the picture, doesn't it? As that bottom number, the x, gets tinier and tinier, closer to zero. You see those red lines just fly off the chart, shooting up to infinity and down to negative infinity. They never touch, and at the exact point where x hits zero, the whole thing just shatters. It's a break in reality. Mathematicians have a cool name for it, a singularity. It's basically the spot where all the normal rules just stop working. But here's the thing. This isn't just some abstract problem for mathematicians to argue about in a classroom. In our world, a world run by code, this mathematical void is a very real and often very expensive problem, especially when it comes to artificial intelligence. Yeah, the source material we're looking at has these great terms for it. On the left, you've got hard maths. That's basically our AI systems today. They're built on logic that just freaks out when it sees a zero, leading to all sorts of errors, latency, even total system crashes. But on the right, that's the dream. Softmax, an AI that the source calls indestructible because, it's just not afraid of zero anymore. And this quote from the material just hits the nail on the head. Artificial intelligence can never be real as long as it fears the void. I mean, think about it. How are we supposed to build a truly smart, truly robust system if its most basic logic has this built-in panic button that just shuts everything down at the first sign of trouble? This fear of zero is a major roadblock for AI. So the big question is, how do we fix this? And the answer that's proposed here is, it's not some complicated bit of code or a fancy new computer chip. It's much bigger than that. It's a proposal to fundamentally change the rules of math. And here it is. It's called the Balabachi axiom. And the rule itself sounds almost too simple. It just says that for any number, let's call it a divided by zero is just a. That's it. So 5 divided by zero, it's 5. Negative 100 divided by zero, it's negative 100. It's such a simple little statement, but the consequences are absolutely huge. This mind map really shows you just how huge we're talking. This one little idea, a divided by zero equals a, isn't just some neat math trick. Look at how it branches out. It touches on mathematics itself, on technology, on real-world applications like AI, and even philosophy. It's being proposed as a whole new foundation for all of these fields. So really, the most important thing to grasp here is the shift in thinking. Classical math looks at zero like a brick wall, a dead end. You run into it and your calculation crashes. This new axiom completely reframes that. It says zero isn't a wall, it's a passage. It's like a bridge that lets the math continue on, uninterrupted. It doesn't break the system, it ensures the system persists. Okay, I know what you're probably thinking. Sure, but doesn't this just break all of math? Well, according to the source material, the answer is a surprising no. The proposed system actually preserves all the key algebraic properties, and it doesn't create any new contradictions. It even forms what's called a commutable ring, which is just a fancy way of saying that the basic rules of arithmetic, adding, multiplying, they all still work in a way that's consistent and predictable. All right, so if the math seems to hold up, what can we actually do with it? This is where we get to the real-world payoff, what the source calls a logic of persistence. So the first big application of this axiom is a new kind of AI architecture, which the source calls DZ20. The whole thing is designed from the ground up on this idea of persistence. And because it's no longer terrified of dividing by zero, it becomes immune to those critical system-crashing errors. And this graph is a great way to see that benefit. So that blue line, that's the AI getting smarter. Its capabilities are growing. But those red dashed lines, those are the technical hiccups, the ruptures, like a division by zero error, that would normally stop it dead in its tracks. But that shaded area in the middle, that's the zone of stability that DZ20 creates. It lets the AI just sail right through those problems without ever crashing. And it's not just about preventing crashes, which is already huge. This chart points to a major gain in efficiency. See, by getting rid of all the complicated code we currently use to dance around the zero problem, this persistent architecture has way lower latency. So the system isn't just tougher, it's also faster and much more efficient. And the potential impact here is just massive. This chart compares how hard it is to solve big problems using the old hard max systems versus this new soft max idea. And look, it's across the board. In everything from algorithms to energy to robotics, this new logic could seriously lower the difficulty, making it easier to make big breakthroughs. This chart really sums it up nicely. DZ20 isn't just a single product or a piece of software. It's being presented as a truly foundational technology, one that could change how we design algorithms, manage energy, build robots, and even how we make the computer chips that power everything. Okay, so this is where things get really interesting, because the idea starts to expand beyond just tech. It becomes something deeper, a whole new way of thinking about problems, about failure, and about continuity. And this quote really captures the philosophical heart of it all. The void does not destroy. It reveals the essence. Think about that. In regular math, the void of zero is pure destruction. It breaks everything. But in this new way of thinking, the void isn't destructive at all. It actually reveals the true identity, the essence of the number you started with. Just look at this graph again. It's labeled with that exact idea. Instead of shattering and flying off to infinity, that red line just keeps going, perfectly straight. It passes right through the void of zero, and its identity, its essence, stays exactly the same. The value just persists. And if you zoom out, the bigger idea here is a whole new way of tackling problems. I mean, what if we started treating potential failure points, not just in code, but in any system, in any project, not as total disasters, but as moments that actually reveal the core truth of what we're doing, moments that allow for a stronger, more resilient path forward. The source material actually frames this as the next big step in our long journey for mathematical precision. From the rough guesses of antiquity to the calculus of the Renaissance, every major step forward brought more clarity, and this axiom is being presented as the next leap, one that gives us a new kind of precision by finally solving a paradox that's been around forever. And all of this leaves us with one last, really fascinating question to chew on. For centuries, dividing by zero was considered impossible, a wall. What we've just looked at challenges that head on. So it kind of makes you wonder, right? If we can rewrite a rule that fundamental, what other impossible limits, what other unbreakable walls are out there, just waiting for someone to ask the right question and turn them into a passage?